So for example 4, where the x is the base and the exponent, it takes much more thought and effort than this because you have a combination of a polynomial and an exponential function. So we have to really take time to look at this and see what our options are. So I wrote it as a function. I'm going to do the derivative of both sides. I can't bring the x down in front in -1 because it's an exponential function. I can't use the rule for my notes for exponential functions because it's also a polynomial. So what I need to do is get this exponent to not be an exponent anymore. And how I'm going to do that is I need to introduce, before I do a derivative, natural log into the problem. Okay, so I'm going to natural log both sides. And the reason I think that having a natural log in the problem will work is then I can use the log rule or the log properties in order to bring this x down in front. So now I don't have an exponential function anymore. Now I just have a product. So over here, the derivative of natural log of y is 1 over y times dy dx. Over here I have a product rule, first times the derivative of the second plus second times the derivative of the first. X over x cancels. I just have 1. ln of x times 1 is ln of x. So on this side I have 1 plus ln of x. And on this side I have 1 over y dy dx. Trying to solve for dy dx, so I'd multiply both sides by y. So dy dx equals this. I'd rather not have a y in my answer if I don't have to. And up here, y equals x to the x. So I'm going to take this and sub it in here. And there is my derivative.